Hi and welcome back to a new episode of the Code in Action series. In this video, you'll learn how to build a simplified version of the Linktree service, the popular website that allows you to share all your personal links and social media profiles from a single page. Our version will be built using Node.js, Express, and Mustache, and will include both a backend API to store and serve your links and a front-end page to organize and display them in a clean fashion. By the end of this tutorial, you will have a working Linktree clone that you can extend, customize, and even publish on your GitHub profile. And with that being said, let's build. So let's start by creating a new directory named Linktree Lite. Within it, let's create a directory named public for storing public assets such as images, and another one named views for storing template files. Within the public directory, let's create a nested directory named avatars for storing profile pictures, and within it, let's add an avatar picture in a PNG format. Let's now enter the project's directory, initialize it, and install the Express package for building the API and the Mustache Express package for converting templates into HTML files. Let's now create a new file named server.js within the root directory, and within this file, let's import the Express package, create a new server instance by invoking the top-level function exported by the package, and bind the server to the dev port 3000 using the listen method of the server instance. Now, in order to keep this project as simple as possible and stay focused on the logic behind each endpoint, we'll use an object literal as database with a single property named users that will contain the data of all user profiles. Each user profile will be stored under a unique username key and contain the following properties: bio, which is a string that contains a short description of the profile; links, which is an array of objects that contain a list of personal URLs; socials, which is an object that contains a list of social platform handles; and stats, which is an object that contains statistics about client IP addresses and link clicks. Let's now declare our first HTTP GET endpoint in charge of retrieving a user profile based on its username and serving it to the client in the form of an HTML file. Within the endpoints controller, let's extract the username variable from the query string parameters object and normalize it using its two lowercase methods. Let's then use the username as key to retrieve the user's data from the database object and respond with an HTTP 404 not found using the sendStatus method of the response object if the username is not a valid key. If the username exists, let's declare an object named data that will contain the data displayed on the HTML profile page, and let's add the username, bio, avatar URL, and personal links to it. Let's then declare a social URLs map object that implements a list of helper functions that take a social media handle and return the full URL to the profile on that platform. Let's then use the methods of the social URLs map object to map each account handle to its corresponding URL on the platform and add it to the data object. Finally, let's temporarily respond to the client with an HTTP 200 OK containing the data object in the JSON format until the rest of the implementation is complete. Now, in order to convert a template into a valid HTML page and serve it to the client, we need to tell Express which template engine to use and how to use it. So let's import the Node.js core path module and the Mustache Express module, and then register the Mustache rendering function as the template engine, set Mustache as the file extension used for templates, and set the views folder as the template folder. Finally, let's not forget to tell Express to serve static assets such as images from the public directory, which will be used to include the avatar pictures in a profile page. Now, within the views directory, let's create a new file named profile.mustache, and within this file, let's write the following Mustache template, where expressions such as username or platform will be replaced by the Mustache engine with actual values such as learn backend or Instagram. Now that everything is set, let's render the template and set an actual HTML profile page to the client by replacing the call to the sendStatus method by the render method and pass it as arguments the name of the template file without its extension and the data object. We can now start the server by passing the server.js file as argument to the Node utility and open the following URL in our browser, which should render the template containing the formatted data. We can now click on each link to test that they work and actually send us to the right pages. Hey, quick interruption guys. I've just noticed that around 80% of the people who watch these videos are not subscribed yet. So if you're enjoying this content, please take a moment and hit that subscribe button, as it will really help me grow this channel and put out more of these projects every single week. Oh, and by the way, if you want to play around with the source code of this project, you can download it directly from the Learn Backend website. The link is in the description below. Thanks a lot for the support, and let's get back to building. Now that our user profile page renders, let's implement visit and click statistics. To count the number of page visits per profile, all we have to do is to store the IP address of each client into the IP arrays of the user in the database object every time a request is routed to the get username endpoint, which will later allow us to count the total and unique number of visits. We can now test that it works by temporarily logging the content of the IP's array and refresh the profile page a few times, which should produce the following output in the terminal. Now, to count how many times the links of a profile page have been clicked, we'll use a mechanism called server redirection. In short, instead of directly displaying the original user's link to the profile page, we're going to generate custom links that point to special API endpoints in charge of counting the clicks, and then we'll redirect the users to the original URLs. So let's declare a new HTTP GET endpoint in charge of counting how many times each personal link is clicked and redirecting the user to the original URL. Let's extract and normalize the username and index variables from the query string parameters object, where index is the index of the element in the links array. Let's then retrieve the user corresponding to the username in the database and respond to the client with an HTTP 404 not found if the username doesn't exist. Let's now retrieve the original URL located at the specified index in the links array and respond to the client with another HTTP 404 not found if the index doesn't point to an existing element. Let's then increment the clicks counter of the corresponding element in the stats object by 1. And finally, let's check if the original URL starts with the string HTTPS, prefix the URL with it if it doesn't, and redirect the user to the URL. Once we've done that, let's move back to our first endpoint so that instead of including the personal URLs in the template, it includes a list of special links that point to the API endpoint we've just defined. We can now test if that works by temporarily logging the content of the links array, restarting the server, refreshing the page, and clicking on the personal links a few times, which should produce the following output in the terminal. Let's now declare a new HTTP GET endpoint in charge of counting how many times each social media link is clicked and redirecting the user to the specified platform. Let's extract and normalize the username and platform variables from the query string parameters object, and let's retrieve the user corresponding to the username in the database and respond to the client with yet another HTTP 404 not found if the username doesn't exist. Let's now copy the social URLs map object from the first endpoint and add it to this one. Let's respond with an HTTP 404 not found if the social URLs map or the user social object don't include the specified platform. Increment the clicks counter of the corresponding social platform in the stats object by 1. Redirect the user to their profile on that platform. And finally, temporarily log the content of the socials object. Then, let's update the first endpoint so that the socials property of the data object contains an array of custom links that point to the new endpoint we've just defined, and test that our new redirection works by restarting the server, refreshing the page, and clicking on the social media links a few times, which should produce the following output in the terminal. Now that we know that our redirections and counters work, let's declare a new GET endpoint in charge of retrieving a user's statistics based on its username and serving it to the client in a form of a JSON object. So within the controller, let's extract and normalize the username variable from the query string parameters object. Let's use the username as key to retrieve its stats object and respond with an HTTP 404 if the return value is null. And let's add a new property to the stats object called visits, and within it two properties called total and unique, where total is the total number of client IP addresses that connected to the server and loaded the profile page, which is indeed equivalent to the size of the IP's array, and unique, which is the total number of unique IP addresses, which can be obtained by converting the IP's array into a set and getting its size. Let's then respond with an HTTP 200 containing the number of visits and clicks in the JSON format using the JSON method of the response object. And finally, let's clean up the code by removing the console log statements we previously wrote in each endpoint. Let's now restart the server one last time, refresh the profile page, click on a few links, and navigate to the following URL, which should cause the endpoint to respond with a formatted JSON object containing all the statistics of the Learn Backend profile. And here it is for today, guys. As always, if this video clicked for you, don't forget to hit the like and subscribe button and drop a comment below. Now, if you're new to programming, you should definitely check out my Skill Search Challenge, a beginner challenge designed to teach you how to write and run JavaScript and Node.js code and help you think like a professional developer in only 21 days. On the other hand, if you're ready to go pro with backend development, you can join the Learn Backend Mastery program, a zero to hero roadmap that will take you from absolute beginner to complete professional Node.js developer in only 12 months. Thanks a lot for watching, guys, and see you in the next one. Cheers!